Hi everyone, this is Melody Rondeau and I'm going to be walking us through this short lesson on applications of systems using inequalities. So our learning intention, I'm learning how to use linear systems to solve real world problems. Make sure you take a minute and write that down. Our success criteria, I can create a system of linear inequalities in two variables in context, very similar to what we did yesterday with equations. And the last one, I can interpret a solution to a linear system given a graph. Again, maybe if you need a second, go ahead and pause it to get that learning intention written, or it will follow on the slides in a minute at the bottom. Here we go. Number one, Tristan went to a grocery store that sells bananas for 50 cents each and peaches for $2 each. Tristan can spend at most $20 and must buy no less than 12 bananas and peaches altogether. Write and solve a system of inequalities graphically. Write and solve a system of inequalities graphically. That means we're going to graph in order to solve. And determine one possible solution and non-solution. Okay, so we practiced yesterday reading the problem more than once to make sure we know what we are answering. So I'm going to go back and read the beginning part one more time, and we're going to focus on what is it that we are trying to do. So Tristan went to a grocery store that sells bananas for 50 cents each and peaches for $2 each. Tristan can spend at most $20 and must buy no less than 12 bananas and peaches altogether. Write and solve a system. All right, so what is the thing we're trying to figure out? This doesn't say it clearly, but we are trying to figure out how many bananas and peaches we can buy. So I'm going to make X represent the number of bananas. And I'm going to make Y represent the number of peaches. Okay, so now that we have that, let me sneak in the word of up here. We're going to go ahead and try to write some inequalities here. So we'll start with the first one. Looking back at the problem one more time, it says that we have some information about bananas. The grocery store sells bananas for 50 cents each and peaches for $2 each. Since neither of those is my total, I'm going to hold on to those in my head and just go on to the next. It says Tristan can spend at most $20. There's my total, so I'm going to put that down. And so this is my at most what I can spend. So then I need to decide this part right here, and please don't write the word spend. I'm trying to decide, is what I spend, is it going to be greater than or equal even to 20, or is it going to be less than or equal? So again, looking for what I spend, can I spend more than 20 or am I spending less than 20? So even though the words say at most, that means that's the most, which is what I spend must be actually less. So I'm going to do less than, but could I spend 20 exactly? Yes, I could spend 20 exactly, so we're going to say equal to. All right, and then what I'm buying for that $20 is bananas and peaches. So if I look at my costs back up there, the 50 cents for bananas, so I'm going to say 50 cents times however many bananas I buy, plus $2 times however many peaches I buy. So that gives me my first inequality. If I continue reading, so I used the 50 cents, I used the $2, I used the $20. Right after it says $20, it says, and must buy no less than 12 bananas and peaches altogether. So 12 is actually my total bananas and peaches. And so what I have to buy then, again, we have that same question, is what I actually buy. Can it be more than 12? Is it less than 12? So we need to make a decision, more than 12 or less than 12. Can I equal 12 exactly? So let's take a look. It says must buy no less. So if I'm buying no less, that means I'm actually buying more. I can't buy less, I have to buy more. So I'm going to buy more than 12, but it says no less than 12, which means I could buy 12 exactly. So this is going to be greater than or equal to. And then let's see if we can fill in some stuff here. So the 12 represents how many pieces of fruit I buy, and again, I'm buying bananas and peaches. And remember, our variables actually represent how many bananas plus how many peaches, and that has to be more than or exactly 12. So those are the two inequalities. And now in order to solve this, we have to do it with graphing. Since both of our inequalities are written in standard form, it's not super friendly to graph. We will do one of them in standard form, but I'm going to take the first one. I'm going to show us two different ways we could graph these. So if you want to follow along, I'm going to grab my colors here. So the first inequality I'm going to rewrite on the side here, 0.5x plus 2y less than or equal to 20. And I'm going to go ahead and solve this for y, putting it into good old slope-intercept form. I'm just going to jot that down for a reminder. Y equals mx plus b. So I'm going to use that as a reference here. So I'm going to solve for y. I'm going to start by subtracting or moving the x to the other side. So I'm going to minus 0.5x from both sides. That gets canceled. I have 2y is less than or equal to negative 0.5x plus 20. Remember, my goal was slope-intercept form, so I put the x part in front. Then to finish this off, I'm going to divide everybody by 2 to get y by itself, and I get y is less than or equal to. This is kind of a weird one. What's negative 0.5 divided by 2? If I cut 50 cents in half, I would have a quarter, so negative 0.25 x is what I have left over. And then 20 divided by 2 is 10. Since we're going to be graphing this, I'm going to turn that decimal into a fraction. So hopefully we know 1/4 or 25 cents is a quarter. So this is negative 1/4 if I write it as a fraction. All right, and with that, I'm ready to graph. I have my slope here is negative 1/4. And that, remember, tells me my rise over run. Sorry, let me scooch over here just a little bit. Okay, so I have negative 1/4. That tells me rise and run. And remember, I'm going to put the negative with the top number, so I'm actually going to be falling. And then the other number I need here is my b value, which is that y-intercept at 10. So I'm going to begin at 10. There we go. I'm going to begin at 10, so go ahead and put a point at 10 on the y-axis. That is our y-intercept. Then using my slope, which is rise negative 1, so I'm actually going down 1, and then I'm going to run 4. Down 1, run 4, down 1, run 4. You can do it as many times as you would like. And then I need to make a decision about what kind of line I'm going to use. Since my inequality, remember the line is determined by what is the inequality. Since my inequality has the equal to, that means I'm going to be using a solid line. So I'm going to do my best, try that one more time, to connect this with a solid line, something like that. There we go. And then we would also need to shade. And so here, if I look at that inequality where I left off at the end, y is less than or equal to. So I need the y values to be less than the line. So that means I'm shading below, something like that. Then I'm going to switch colors over to green. And with my green, I'm going to go to the other inequality. And you may not have a ton of room. Hopefully you can squeeze it in here in the space that we have. I have x plus y is greater than or equal to 12. For this one, I'm going to do what we learned with standard form, and I'm going to do intercepts. So I'm going to find the x-intercept, and I'm going to find the y-intercept. So I'm going to use a slightly different strategy for this one, although we could write it in slope-intercept form and do it that way as well. I'm just going to show us one other strategy that might be helpful. All right, so if I want the x-intercept, hopefully we remember, we've done this enough times, that I'm going to make y 0, so I just have the x here. And so I end up with x is greater than or equal to 12. And then for the y-intercept, I make the x 0, and I end up with y is greater than or equal to 12. So even though it has the inequalities, we're going to treat it as if it just says equals. So I'm going to go to my graph and I'm going to go to x equals 12 and put a point, and y equals 12 and put a point. And I have to make a decision once again about what kind of inequality, what kind of line I'm going to draw to connect these points. So as I look at this, my inequality is greater than or equal to. Since it has the equal to, I'm going to connect with a nice solid line, and I'm going to do my best to do that. We'll see how that goes. There we go. Sorry, a little technical difficulty there. Let's try this one more time. Wow, that's not very straight. That's a little better. Cool. All right. So now that I have that drawn, then I'm looking to shade. Now this is a little different too because I did intercepts for the green equation in standard form. I need to decide whether I'm shading above or below. So we talked about reading the inequality. And so that only sort of works in this particular case. So another way we can do, another way to decide where to shade is to test out the point 0, 0. So I'm actually going to plug in 0 for x and 0 for y and see what happens. So I get 0 plus 0, which is 0, is greater than or equal to 12. And then my question is this true? And the answer there is no. Whoopsie. No, it is not true, which means since this is not true, 0 is not greater than 12, I cannot shade the side that has the point 0, 0. So 0, 0 is right here. I cannot shade that side of the green line. So I'm going to have to shade the other side. So I would shade above. Now, if it was true, we would shade the side that had the 0, 0. So it kind of gives us another way to test it out. Since it was not true, we don't shade. If it was true, we would shade. All right, so what I'm looking for then is where those shadings overlap. And so this case, my shadings overlap in this section right here. Whoopsie, got a little crazy with my shading there. Try that one more time. So that's where my shadings overlap. That is my solution. You may recall we talked about that, where the shadings cross. That is the solution section. For the last part of our work today, we're going to be looking at a point that is a solution and a point that is not. So let's go ahead and check that out. Possible solution for the system, and notice it says written in a complete sentence, and a non-solution. So let's figure those out. Let's go back to our graph. I need a point that is a solution and a point that is not. And so I'm going to just grab a point that is a solution, would be anything in that shaded region. I'm just going to pick a point that I can easily mark on my picture there. There's a point that would be a solution. And then a point that is not a solution would be anything not in that purple section. So I'm going to be boring and actually pick 0, 0. I like to pick 0, 0 because it's usually pretty easy to do. So there's my other point that would be a non-solution. So the point that I picked here that is a solution, let's see, that's at 10, 11, 12, up 1, 2, 3. So 12, 3. I'm going to jot that down in my answer over here. So the point that was a solution, I have 12, 3. And the point that I'm choosing that's not a solution is 0, 0. All right, so then when I go to write this into a complete sentence, here's what I might write. So actually first let's go back and read. We were talking about Tristan. He went to the grocery store that sold bananas and peaches, and he could spend a certain amount of money, and he had to buy a certain amount of fruit. At the end, write and solve a system of linear inequalities graphically and determine one possible solution and non-solution. So I might say something like this. Tristan can buy 12 bananas and 3 peaches. Since this is more than, sorry, I forgot the number, I got to look back, more than 12 pieces of fruit. So, or I could say bananas and peaches. So this is more than 12 pieces of fruit and will cost less than, and I already forgot the number, so I got to go back and look at the number, costs less than $20. So not only am I saying the solution of 12 and 3, but I'm putting it in context, so 12 bananas and 3 peaches, and I'm also saying, noting how it reaches the criteria that we set. In fact, on the second one, I'm going to use that word criteria. So the criteria was we had to have more than 12 pieces of fruit, more than 12 bananas and peaches. In fact, I might even, sorry, I know I put pieces of fruit, but I might even change that just to make sure it's super clear. But you're fine if you wrote pieces of fruit, that's what I wrote, but I'm going to switch it. I think I like bananas better. Bananas and peaches. There we go. And will cost less than the $20. So those were the 2 things we had to do. For the non-solution, I would again talk about Tristan. Tristan cannot buy 0 bananas and 0 peaches. And when we're saying that it doesn't work, we only have to show that it doesn't work for one of the criteria, because as long as one of them doesn't work, it doesn't work for the whole system. So he cannot buy the 0, and then you have your choice. You could say because that he's not spending, I mean, he is spending less than 20, so that's not the problem. It's because he's not buying enough fruit. So actually, we don't have a choice. We have to pick the one that this violates. So specifically here, Tristan cannot buy 0 bananas and 0 peaches, since this does not meet the criteria of buying more than 12 bananas and peaches. So there you go. So again, not only saying the 0 and the 0, but also giving the reason and how it connects back to the problem. All right, so that finishes our notes. If you need a minute to write, you can go ahead and pause it. Let's take a look at our success criteria. Please do this in your notes. Double check those success criteria. I can create a system of linear inequalities in 2 variables in context. I can interpret a solution to a linear system given a graph. If you feel like you've got those, go ahead and check them off. Otherwise, circle them and go ahead and check Google Classroom for what is next. We'll see you guys later.